Okay, this one that I'm doing is 37.2. This one says a positive muon is unstable particle, lives on average 2.20 times 10 to the negative 6 seconds, and that is measured in its own reference frame. So 2.20 times 10 to the negative 6, that is delta T naught, because that is measured in the particle's own reference frame. And then the first thing that it asks us is if it's traveling at a speed of 0.900 c with respect to whoever saw it in the lab, we want to know how long the particle lived with respect to the person who saw it in the lab. So we're going to use this equation and then put our mu signal, or I really don't know what that's called, I forgot. And what this is really equal to is 1 over the square root of 1 minus u squared, which this is our u. So this is going to be 0.900 c, and that's squared, and all of that's over c squared. So then we're just going to solve that, plug in our numbers. So our delta t is equal to our t naught, which is right here, 2.20 times 10 to the negative 6, and that's over the square root of 1 minus, and then these c squareds are just going to cross out. So then we're just going to square this 0.9, which makes this 0.81. So then we can just reduce this square root, and then this is going to be 0.19, I think. Yeah, anyways, the calculator does it for us, and then when this calculates out, we get that the time that the laboratory person experiences is 5.05 times 10 to the negative 6 seconds. That's how long the person in the lab sees that the particle goes. And that's part A. Okay, and part B says what average distance measured in the laboratory does a particle move before decaying. So our distance equation is going to tell us the change in the x direction, that's our distance, that's equal to the change in time experienced times the velocity of the particle. So our delta x, what we're solving for, is equal to the time that, the lifetime of the particle as measured by the lab, which is the number we just barely calculated. And then I wrote that really big. This is being multiplied by the speed of the particle, which is 0.900 times the speed of light, which we'll just put in over here, 2.998 times 10 to the 8th. And when we calculate all of that out, we get that our delta x is equal to 13,062.591 meters, and that's how far the particle can travel.